So now we'll start with Dan and Barrett. Thank you, Dan. Thank you, Barrett. And you can start now. Thank you.
All right, great. Thanks, Ahmed. Thanks for having us. So as Ahmed said, we're going to talk today about using UAS, artificial intelligence, and digital twins to improve infrastructure projects. So our learning outcomes today are we're going to talk about how we're using 3D deliverables and AI in practice, and we can go through some specific project examples on how we're integrating it into the project workflows. We'll talk about electronic records, digital twin field tools and software, and then we'll go through some specific projects and talk about the risks and benefits to each of those projects. And if you have questions, please save them for the end or put them in the chat, and we'll hopefully answer everybody's questions at the end. So the first thing, this concept of a digital twin, at least to me, the definition of a digital twin is a digital representation of a physical asset. And that physical asset can be anything really in the world. For us, it's usually some type of infrastructure, whether it's buildings, roadways, bridges, sign structures, anything that we want to model, we can call a digital twin. And usually that digital twin takes the form of a 3D point cloud or a mesh. We can make it geospatially correct. We can use surveying principles and ground control to make it as accurate as we need it to be, and to make it accurate for measurements, but also accurate in the world geospatially. And we can use these digital twins as part of our projects. We can use it to annotate things about the structure or asset that we're trying to communicate about. And more importantly, we can share all that information, usually through the cloud, where everybody in our project team can kind of collaborate and communicate around that digital twin. So, we're collecting this data, and then we're post-processing it into a digital twin. And for us, we're using iTwin Capture a lot, which is a Bentley product, but there are lots of different software packages that we use and that can be used to post-process all of this information into a digital twin of that asset. This is just an example of a bridge in New Mexico. It's the Rio Grande crossing. And so just showing what that structure looks like in the video, but also what that digital twin looks like. And as you can see, it's just a 3D model. And in this case, we're annotating it with inspection information and sharing that model and that inspection information with the owner of the bridge. So it can take the form of a lot of things. This is a bridge that we did in downtown Chicago. It's LaSalle. And this is maybe an example of how we can use the digital twin, or create a digital twin, even in a dense urban environment with lots of people around. In this case, we have traffic and boat traffic, even pedestrians, but we can safely collect the data with drones, even in that challenging environment. We can also do things like sign structures, really anything that we might find in a transportation corridor. We can collect and create digital twins of those assets. One of the real benefits that a digital twin can bring us is being able to monitor change over time. In this case, we have a bridge that's downtown St. Paul. It has some pier caps that are a little problematic. And so So we wanted to monitor them. And if you're familiar with inspection, we might traditionally take some pictures that we might put in the appendix and have a lot of notes and descriptions of things. But a lot of times that information is not enough to really be monitoring how much the bridge has changed over inspection cycles. And in this case, we had an inspection uh, time of about 6 years, so we could really see how much has changed over that time, and really be able to measure how these like concrete spalls have changed, and how the concrete cracking may have changed over time. Um, and that's something that, again, is difficult to do in a traditional manner, and we can do it with the digital twins much more accurate and much more confident that something is actually changing, or maybe it's not changing. And we're using AI as part of this process, and there's two different ways that we're using AI. The first is for data collection. In this case, we're using Skydio drones to automate the data collection process. Drones can collect data in magnitude, orders of magnitude faster than humans can, and I would argue that we can do it faster and more accurately. In this case, we had a bridge bearing that we wanted to look closer at. Obviously, it's very difficult to access without expensive access equipment. So we go out with the drone, and we fly the drone to the corners and to the top and bottom of the area that we want to model. So in this case, we just went to the four corners around this bearing, and a floor and a ceiling. And that defines the volume of what we want to collect, and then we just tell the drone to basically fly in that volume, determine what's in that volume, and then it will make a plan for collecting all of the images that we need. And when we're collecting images for a digital twin, we want a lot of images with really high overlap in order to build the model. So now the drone is just flying completely autonomously and is taking all these images of that bearing that we need to make a 3D model. And at this point, as the pilot, we're just monitoring the flight and waiting for it to finish. So, this is a pretty significant change in how we're doing all this work, and how much autonomy is involved now. And we get much more consistent results this way. And so we take that data, we post-process it in the software into these models, and then we can start to share that data on the cloud. This is us just sharing a bridge deck of a bridge in St. Paul, Minnesota. And so in this case, we're only modeling the bridge deck. It probably took less than 15 minutes to fly this whole bridge deck structure. We model it, we share it, and we can start doing things like applying artificial intelligence to automatically find defects, or we can just view the defects in the model. And you can imagine, it's a decent sized bridge deck. To be able to go out there with inspectors and find and measure and annotate all of the cracks in the bridge deck using traditional methods is very time consuming. It can be difficult from a safety standpoint, because we either have to close the bridge, or we have to have people working near live traffic, which poses a lot of safety risks. But we can do it this way, and we can get I would argue better results, and much faster, and more accurate too. And this, I'm just jumping ahead to show this is what the artificial intelligence crack detection can show us. So it finds all the cracks, highlights them, and then quantifies them for us so that we can use that data, whether it be for repair or crack sealing, something like that. So I'm going to go through how we're integrating this into a specific project. This is the Robert Street Bridge project where we are working with Michael Baker, and we're doing a load rating, where we did a inspection and load rating, and then a plan for the bridge. So our workflow, which is a little bit different than traditional, is the first thing we do is we go out, we collect all of the data in the field with the drone, and then we create these digital twins. In this case, we had, I think, about 8 or 9 of these arch spans, and we collected the data and post-processed them individually by span, and then kind of bring them all together in a viewer. And then I think the most significant departure from our traditional methods is we do what we're calling an office pre-inspection, where we're taking these models, we're having our inspection engineers, before they ever go in the field, do as much inspection from the model as they can. So they're finding defects, they're drawing them out on the model, we're getting quantities for them, knowing that we may not get everything in the office, or we may want to check things when we're in the field, but we're getting as much as we can before we go in the field. And then our inspectors go in the field, they have access to all these models through tablet computers and the internet connection. And then while they're in the field, they're just verifying that these inspection notes that we created are correct. And then, or finding new inspection defects or conditions that they're noting. And then we're integrating all of that into the bridge management plan, and eventually we'll do rehab design plans, and then we'll also use the digital twins for construction. So this is just kind of highlighting that process. We're not eliminating the field work. We're still going out there with snoopers, but we think we're making it much more efficient, and we're not having to spend as much time in the field as maybe we normally would. And so there's a cost savings related with that, and safety improvements as well. On the upper right, you can see the model with some of the inspection information. On the bottom, you can see one of our engineers doing some of that pre-inspection that I discussed. And this is what it looks like on the cloud platform with just one specific defect. This is a spall or DLAM that's forming on one of these columns. And so we in the middle there, you can see the defect drawn out. You can see it, the inspection notes on the left. And then on the right, we have access to all of the original images that we took by just clicking on that part of the bridge and seeing all of those images that are associated with it. And again, we're using artificial intelligence to find a lot of the defects as well. This is just running the crack detection. We're highlighting all of those cracks. And, a question we often get is, how accurate is it? And I would say artificial intelligence isn't, 100% accurate, but we have our engineers go through and look at all these defects, and they can manually remove them if we don't think it's really a crack, or we can add cracks as well to make it more accurate. And if you've ever done an inspection, or you can just maybe kind of imagine like measuring all of these cracks that go lots of different directions, can be difficult to do accurately with just a tape measure, and then trying to sketch it out or something is inherently not maybe as accurate as we'd like it to be. So in some ways, we could consider the artificial intelligence is already more accurate than traditional ways. We can also use it for doing finding and documenting things like concrete spalling. And in this case, we're finding all of the spalls on the underside of the deck, and then we're quantifying them. And really, we can train the AI to find really anything we want, whether it's defects, or we could look for things like signs or other kinds of deficiencies of the bridge, and it will highlight for them for us. And the way we're doing that is we're just having engineers go through pictures and identifying these types of defects. And the more we do, the more the AI learns from the engineers what those things look like that we're trying to find, and then can automatically do it by itself. So some of the benefits that we're seeing, we estimate that there's about a 30% cost savings from the inspection efficiencies. The thing that I think is harder to figure out, but it probably has a more significant impact on the cost, is the additional cost savings from the data being easier for us to digest. So especially on the bridge I showed, you can tell there's hundreds of these defects. Not all of them are critical or important, but we can easily sift through that data and highlight that data so that it's we're having a lot of cost savings that way. And one of the things that we've noticed is we just have less conservative decisions about things. When an engineer doesn't have a lot of information, we tend to make conservative decisions about how to repair stuff, and we don't have to do as much of that because we have better, we have pretty significant improvement in the quantity and quality of data, and we can use AI to start to address staffing shortages as well, because we don't want our best and brightest engineers spending a lot of time doing things like measuring, sketching cracks. We want to make better use of their time. And then, we found that these workflows tend to attract staff. It's more fun, I guess, for the younger engineers to be able to do things like use drones and AI as part of the project. And then there's pretty big safety improvements. And then eventually we'll see construction savings as well. And with that, I'm going to hand it off to Dan to talk about some of the applications.
Thanks, Barritt. Can you hear me? I think we're good. Good afternoon. As introduced earlier, I'm Dan Kucza. I'm a professional land surveyor, so I have a little bit different background than Barritt. I'm a licensed land surveyor in several states. My part of the discussion, I'll focus on survey tools and deliverables. So, I've been making electronic files for my whole professional land surveyor career, and I feel like now they're calling them digital twins. So I welcome that discussion. We'll try to give a sense of where we see digital twins making a positive difference in projects, and both today and in the future. Next slide. So we're talking about 3D deliverables, and hopefully the people on this, I'm sure there's different people from different backgrounds listening to this, and some have worked on small projects, or some have worked on large projects. Some have big budgets and big scopes. Some have small budgets and small scopes. And I think those are factors that are affecting the quality of the digital twins on projects. So I think it's something we need to look at. Some states are having owner specifications where there's requirements to do it. I think no matter what, we see the uses increasing, and which I think because we're, standard of care is doing what everyone else in the industry is doing in a similar circumstance. I think, by way of this technology, the standard of care is increasing. Next. So talk about some of the softwares that have been around a long time. I find it interesting that all these companies on the left, Trimble and Leica and Topcon, they've sort of been around for the same amount of time. They provide sort of the same products, and then they work with the National Geodetic Survey and NOAA government agencies to sort of help control our coordinate systems across the country. In the middle, we have there's design software. So probably everyone on the call is using either Civil 3D or Autodesk, AutoCAD, or maybe they're using MicroStation, but those are the two major players. And then on the right, we're seeing some emerging technologies. So as Barritt showed on the inspection side, we're using drones to make digital twins. Also in the construction side, folks are using drones to get quantity data, to get progress data, and to just have more information about their job sites. Next. So this slide, I'm just trying to go talk about the tools that we're seeing, right? So I always like to talk about on the left, you really can't get away from using a 6-foot rule in a field. You can't get away from using a level, and a wheel is a really helpful thing for an inspector, but those are sort of historical tools, right? And in the middle, we show what we at Collins are doing now is our construction management staff are getting equipped with a GPS rover that, me as a surveyor will help them to calibrate it, make it work in the right way. Well, we can export digital twins from our designs and put them in there, and that assists our construction inspectors in the field. On the right there, I'm showing some of those tools. So as Barritt showed a lot of examples of, there's drones. At the end of this, I'm going to show a use of construction use of augmented reality, which I thought was pretty neat. And we'll just try to show some projects where we've had some success. Next slide. Okay, so here's the projects. We're going to do a bridge deck. We did a bridge deck where inspectors had to measure the size of those repairs. We're going to talk about a project in the city of Wauwatosa. That was a project where older project. So a lot of early drone work for me was us just getting drones out on the project safely and seeing what kind of value they provided. So we have an example there on a streets rehab project. I'm going to dive deeply into Wisconsin DOT State Trunk Highway 20 project. We did some really high quality drone flights there. We used them in a civil way did some concrete quantities for the contractor. So we'll talk about that. And I think the I-43 AR construction, that'll show the how we're using models, exporting them into things that are simple as a cell phone and trying to use that in a geospatial way. So, next slide, Barritt. All right, so the first project is Waukesha County. In Waukesha County, Wisconsin. It was a bridge deck rehab, and it's a smaller bridge deck rehab project, and they're typically done in halves. The existing concrete surface is milled down. Areas of concrete delamination need to be repaired. So our inspectors are out there and they need to document type 1 and type 2 repairs, which you can see in the picture on the right. The milling machine has gone through there, and then you can see where the concrete broke away from the rebar where it was delaminated. And then we have to measure those shapes. Type 1 versus type 2 is a big cost difference, but it's all we have to look at if it's below the rebar, above the rebar. So it becomes a very complex measurement. I guess normally, I guess we would have a field inspector would have a field book and a tape. And so if you look at the shape and the ortho photo on the left there of these shapes, they're pretty hard to replicate. As Barritt was saying earlier, they're nearly impossible to replicate. And so what we were able to do is do a drone flight, create an ortho TIFF safely over the non-moving traffic, and then provide this exhibit to the contractor and to our inspectors to give them another measurement of the quantities. You know, we completed the scope conventionally. We also did it with the UAS map, and we found the UAS mapping to be more reliable method. It didn't miss little areas. Next slide. This is a project that I mentioned earlier. Was I went out there and I was helping a younger inspector. We were, again, just sort of trying to look for value in construction management, figure out if we could fly safely over construction sites. And in doing this small roadway, we ended up choosing one that was a smaller project that had a young engineer without a lot of experience because it was out of the way, I guess, right? And what we decided to do was do monthly flights that made that data available to the project team. One of the excellent uses that we found was tracking removals for the utility trenches. So on this project, our utility inspector was required to measure the water trenches from the storm sewer repair trenches, from the sanitary removals, all separately, because the city needed to track those to different funding sources. He had the inspector carefully marked them out, color coded, and some rain looked like it was going to come, and the contractor was cutting faster than the inspector could keep up with. And he asked me if I could get out there and just do a drone flight. So I was able to get out there. And what you see is the model that we were able to create, and then some of the shapes that we were to create, right? We would trace along the edges of those trench removals that we could see in the flight. And then we would get a square footage number that we could enter into our spreadsheet. So it ended up to be an unexpected, kind of a cool use. Next slide. So the next project I'm going to talk about is I'm going to do a little bit of a deep dive here. So hopefully if folks are looking to get into this work, we'll give you some of the features of how this went, or the details that were required to know to get it accomplished. So this is a project that was about a $10 million construction project, and we were assisting the contractor with construction layout. At the start of the project, I was flying small UAS missions because I had good survey control in the area. It didn't cost more to get it there. And on my own time, I could do some flights and kind of test the accuracy of those models that I was developing. And I found that I could develop fairly accurate models. We also found that on the left, you're seeing we use Pix4D Cloud for construction projects. It seems to be a nice tool because what you're seeing there is a drone flight, and then we can upload a PDF overlay. So we have the plan set right over the top of the latest conditions, which is really useful for our inspectors. Next slide. At the completion of the project, we were hired by the general contractor to try to do a drone flight as built to try to help them verify quantities for payment. It turned out it was a real busy season, and the contractor didn't have the records that they wanted, and so they wanted an additional check to see that they were getting paid for all the work they had done. We discussed and agreed to a scope of deliverables and fees. We kept all of the work to two-dimensional because all of his concrete quantities were two-dimensional. And so we decided we would map a series of roadway features that were measurable, that we could check quantities, right? So next slide. So here's some of the technical details on that. Wisconsin in particular, at the time of this project, was a little bit more reluctant of drone flights. So we were real careful to do a safety planning. We chose a height above ground level that would be able to allow us to map areas that were open to the traffic without flying over them. So we were able to get the overlap that we needed through collecting the 1,290 digital images, right? We set 18 targets after, of course, getting WISDOT approval for doing the mission. So there you see a GPS rover shooting one of my homemade targets, number 10. We just put an accurate coordinate on that, and then the Pix4D cloud system in particular post processes from there. Next slide. These are just some screenshots from my phone while working on the project, right? So it was, not a little job. There was a lot of closed areas. So there was corridors where I could fly without being over cars. But it was, my goal with these photos is to show you that if you're a construction manager and you're getting like a monthly or a weekly flight, you can use that model on your phone. We're able to send that link to the construction management team, and they can just zoom back and forth from one end of the job to the other to take a look at current conditions. It doesn't replace people in the field, obviously, but it is another tool that helps people get kind of like a bird's eye view of what's going on the job. Next slide. Here, and what we're showing you is, this ortho photo. And so then overlaid over that, this is a screenshot taken out of Civil 3D. This particular design was done by a consultant for WISDOT. WISDOT, I believe, dictates Civil 3D use, right? And so we had this model that was the design that we had been using for doing construction layout. It was in Civil 3D, and we were able to export the GeoTIFF file out of our drone flight and then use it as a background here. It's to scale, right? So then I could have a CAD technician go in there and measure the polygons. So the shape of the driveways versus the shapes of the pavement versus the shapes of the sidewalk. Those are all different pay items. And it's kind of like a puzzle. So it's, it's kind of easier to measure it when you're looking at it, from a bird's eye view as one thing. Next slide. So this is just showing some of the results. A lot of people ask right away, what type of results. So, we had, I said 18 points across the project, which was about a little, like 1.25 miles. I staggered the points, and then I just shot them with the GPS rover, which to me should get those points within 1/10 of a foot. And then I went back and shot those same points with a level, to verify that. And I also was able to measure the coordinates of my digital twin model to verify and look for error. And so you're seeing there 0.101, it was about 2 inches off in the northing, which is pretty minimal when you're talking about a $10 million job this long. So we're pretty comfortable that our stuff was to scale. On the right, what I'm showing you is the spreadsheet that we ended up getting from the contractor. So I know you can't read it, but if you were able to, you'd see that there's all the different items are in the columns, and the rows are just, there's a plan number, right? And so there was a plan design number, and then there was a measured number by construction managers that were another consultant in the field. Then there was another column where there was a number measured by the contractor's field staff. And then the final column, the final row was UAS. So we went through and did all these calculations, and we found a number of areas where the contractor was actually underpaid. One area in particular was something called pedestrian curb, which is a very unusual item. It's hard to see. And we measured it. We came up with a quantity of 1,800 lineal feet. The funny thing is the designer had about half of what was really there. All the other players on the thing had missed that particular item, and not throwing stones at them, but again, just hard to see everything when you're constantly measuring and constantly changing the project. So having that as built at the end was really, really nice to have a record of what we did. And that's what, next slide. And my final slide here, I'm going to talk about something that is something up more towards the future of augmented reality and using digital twins. I-43 is a freeway. It's about a $60 million construction project. And we were working on that doing survey quality control. So we were responsible for checking the contractor's construction layout and their construction to make sure that it was within tolerance of the project specifications. And wanted to give a little bit of a background. So I don't know who's on the call, but on the right upper part, that's showing an overpass bridge. It's the plan. It's a screen snippet taken from it, right? And the yellow in that is a driven shell pile. And the top of that in green, that's the sill abutment. So that's an abutment that the beams for the overpass bridge are going to have to sit on, right? And so I thought I'd give you that little background before we show you. We were able to take a digital twin of that design from the designer and import it into something called the Trimble Sight Vision. So the Trimble Sight Vision is in the lower right. That allows you to take an Android phone and it sort of geolocates it based on a GPS signal, plus looks at point clouds. And then it can project the digital twin design in the real world where the proposed improvement is supposed to go. And so we have a video of that that we want to play next that will show that. So here you see I'm standing on the grade. They've filled up the overpass where they're going to build. The pile are already in there, right? And so there's a little bit earlier photo where they haven't filled yet, but you can see that those are the pile. And it has this augmented reality view in it. And so that at the end here, you turn that augmented reality view, as you point the device, it shows you where the pile should be placed. And so as you get up closer to it on this one here, I can see that, the one of the piles was about 6 inches off. And so we were able to expose that through the use of basically an Android phone. And so that was a really neat use of a digital twin. Took a lot of cooperation. We had to, do a lot of signing off that we weren't going to use the digital twin for anything other than exploratory purposes. But at the end of the day, we found that this probably is the future of how construction inspection might be done. And that's the end of my presentation. So if anybody has any questions, I'm open.
Thank you both, Dan and Barritt, for such amazing presentations. We love to see it. If anyone has any questions, I ask that you put it in the chat or click on the Q&A portion and submit it as a formal question. Or if you would like to speak your question aloud, feel free to raise your hand and I'll be sure to unmute you. Take a few moments to see there. Okay, we have a question from Earl Burkholder. Earl, you should be able to talk. Can you hear us okay? Oh, maybe not. Hold on. Great. Fantastic. What is happening? Hello?
Yeah, I'm here.
Yay! Awesome.
Okay, I was going to put into the chat how much I appreciated the presentation, but according to my screen, my chat is disabled. So kudos to the presenters and to ASCE and UESI for sponsoring the webinar. Thank you.
Thank you. And thank you for highlighting that the chat is disabled. I did not realize that. We love it when we have technical difficulties. There we go. Okay. So everyone should be able to type in the chat now. That being said, we do have another question submitted from Kevin Gallant. The question reads, it sounded like some clients were skeptical for use at first. What was that transition to using this technology more?
Maybe I'll answer first, and then I'll let Dan answer from his perspective. But they're definitely, when we introduce a new method or a new way of doing things, I think there is a learning curve that, depending on the team member, some people embrace it right away and jump in, and other people, it's maybe more of a struggle and want to go back to the traditional way. But what we've found is that as soon as people get into that digital twin, when it's on the cloud, and they start to realize that they can do things like make measurements and look at things, and as they're doing their part of the project, and then I think it just really clicks with them how much of value is. And what we've found on some of these projects is maybe there's a little reluctance at the beginning, but then we keep getting requests to add people to the project. So there's, we went maybe from having 5 or 6 people that we thought would use it to 30 people that are using it for things that we didn't even maybe consider that they would use it for, like environmental, public involvement, those kinds of things. So I think the big thing is just once people start using it, then they really want to use it more.
I can add to that. I mean, my slide that tried to show that BIM use, building information modeling use, is increasing over the years, is just trying to answer exactly that question. That if you try it, people find success. And I think there are failures along the way. And so but my experience has been that the upside is so great that when you find it, it's worth it. So I would say that any digital twin creation is a good digital twin creation. And, we have to be mindful, or the clients have budgets, and we have budgets, and, we can't do everything we want, even if it would be better. But helping them along to understand where that value comes, I think, is the secret to that.
Okay, thank you both for answering that. We have another question that came in that reads, are there any certifications or licenses that someone should have in order to do this type of work? It seems that anyone can claim to be an expert, and as an owner, we're worried about the quality of work that we receive. Also, do you have any sample scope of work documents for this type of work?
Yeah, I can answer. I guess the biggest thing for us as a company is that we've approached it maybe differently than other companies, where we're training our staff to use drones and use digital twins, but they're already the experts in whatever discipline we're using it for. So if it's for bridge inspection, they're already either bridge inspector or bridge engineer that are just learning to use the drones as a tool. So they already have all those certifications and that industry knowledge, and we're not, say, hiring a drone company or a drone pilot to give us data. And we think that that gives us much better outcomes, because we understand from the beginning what we need out of it, and what the deliverables need to be, and what the accuracy needs to be. And that accuracy can be different whether we're doing a bridge inspection or a survey. Obviously, there's a lot different requirements for those, but as long as we understand the requirements up front and then approach it that way, I think we get a lot better outcomes.
Yeah, I'd say that we've found, I mean, there's a lot to know to be a safe drone pilot. And so I think in the beginning of using a tool like that, it becomes the center of what you're thinking about, but it's really just a tool. I don't think that my tool use as far as using a drone, or my software use as far as using any of those softwares, the license, the PLS is what I think is relevant, where it's what we try to do is get, like all companies, we have trouble finding staff, and we have a lot of young staff doing a lot of stuff. And if we can do it in a more interesting way, and then it is more efficient, that's a big benefit for our company.
Thank you both for that. And thank you everyone for such good questions and comments. Is there anything else? Oh, got another one coming in from Joel, I believe it's Koning. It's in the chat, but it reads, in your last slide showing the piling, the element was above grade. If we had a robust SU program and 3D modeling of existing or proposed utilities, would we be able to visualize these in the field even if they are below grade?
Trying to unmute. Yes. Yeah. I think that's a good question. And I think the answer is yes, but remembering that this is a utility engineering group, right? And utilities are typically underground. And then so to measure them as a land surveyor, anybody, is very difficult. You can pothole them or you can dig them up. So it becomes very challenging to use data of existing stuff. That's why, in my experience, I've used a design. If you work on a giant project, in this case, we were, the designer was HNTB. They are a outstanding modeling company, and so working with them, they had that model, so it didn't cost us anything. It was something that existed, and we were able to just utilize it. And we knew we'd spent a little bit of time maybe checking it so that if it was a 3D model that was visual or actually to scale and correct, we'd have to verify that. But once we did that, then it became a really useful tool. And we can measure stuff below ground. So then on the jobs that we do, we try to measure as-built. Every time there's a storm sewer placed on the grade, we'll shoot that, and then we can add that to a GIS. And the thought there is as if that information is more accurate, then later it should be lower cost to get that information for the next project, right? So it's kind of like a continuous circle.
Awesome. Okay. Thank you, Dan, for that answer. Appreciate it a lot. Are there any final questions or comments? As I try to make sure that I am not missing anything. All right. If that's good, then thank you everyone for attending. We really appreciate it. And we hope that you learned a lot today. Dan or Barritt, if you have any final comments at all, feel free to give them.
Nope, just thanks everyone for attending.
Thanks a lot, and feel free to contact me if you have any questions about any of this stuff. You can find me on LinkedIn. I like talking about it. Thank you.
Amazing. Okay. Thank you, everyone.